So the slope of a graph is the mathematical relationship between two variables. In our examples here, the two variables are distance and time. You notice in the first graph that the line slopes upward, and in the second graph the line slopes downward. What this tells us is that as this variable, in this case time, increases, the variable on the y-axis, in this case distance, also increases. In this graph over here, as the variable on the x-axis increases, time, then the variable on this y-axis, distance, decreases. You can find the mathematical relationship using this equation. The slope of the line is equal to the change in y over the change in x. In other words, y2 minus y1 over x2 minus x1. So in our first example, we choose 2 points on this line. Now it's a computer-generated line, so we could pick any 2 points we wish. In this case, I like 0, 0, and probably this farthest one that seems to be about 7 seconds and 35 meters. So we'll write 0, 0, and 7, 35. So our slope is going to be y2 minus y1. In this case, we have our x2 and our y2, our x1 and our y1, just going from left to right. So we take 35 meters minus 0 meters divided by x2 minus x1, 7 seconds minus 0 seconds. And so our slope ends up being 35 meters divided by 7 seconds, which is 5 meters per second. In this example, our x1, y1 is going to be 0, and looks like about 125, and our x2, y2 will be 2, 0. So it's very helpful to write down the actual coordinates before you do this math. Our y2 is 0, and it's on the y-axis, so that's meters, minus 125 meters, divided by our x2, which is 2 seconds, minus 0 seconds. So we get a negative 125 meters divided by 2 seconds, which comes out to 62.5 negative meters per second. In other words, this object is moving backwards, which is shown by this. The distance is decreasing as time goes on. Moving backwards, we get a negative slope. Now slope, of course, in our line equation, y equals mx plus b, this right here would be where our slope goes.